So for last two prefixes for 100.1.4.0 and 5.0, I'll perform prependation on R5. So I have matched all those two prefixes with this access list, 100.1.4.0 and 0.0.1.245. I'm going to create now route map. Let's say route map is its name is AS path, right? Permit, because we are not performing route filtering, so we have to permit all of them. Say match IP address, set AS path prepend. As I said that you must prepend same AS path, right? So I'll be saying prepend 65500 65500, because we will be giving all these prefixes to our eBGP neighbor BT after prepending 65500, right? And we want it to prepend some more ASs, so I am prepending same ASs actually, right? So I have taken 65500 over here. Fine. Then all other prefixes must be advertised with the default attributes. So to allow all others, create one another statement of the same route map with higher sequence number. By default match all is there and we don't need to set anything else, right? Now you go to router BGP 65500, then say neighbor, that is 200.105.100.1. That is an IP address of, right? So now say route map name is in which direction? Because this time we are advertising these prefixes towards our eBGP neighbor, right? Then say do clear IP BGP star out. Do show history. Is there any problem till now? Fine. Let's move on R6 now. On R6 we have to perform prependation for first three prefixes, right? So I'll be saying access list 10 permit 100.1.0.0 0.0.3.245. So you will see that first three prefixes will match with this statement, right? And then say route map name is permit match IP address 10 set AS path prepend 65500 65500, and to allow all other route map permit with higher sequence. Go to router BGP 65500 neighbor, I think its IP address is 201.100 201.100.100.1. route map name is in which direction? Do clear IP BGP star out. Fine. Now I will prove it from New York router. Router BGP 8127. To get reply, actually I have to advertise this 80s prefixes word. To get reply, right? Otherwise, because in short it will pick this address. So now trace route 100.1.1. It should go via R5. You see, it is going via R5. Is not it? Yes. For 2.1, of course, it must go via R5. It is going via R5. However, it will not be successful, right? Because there is a black hole. It is also going via R5. For 4, it must go via R6. For 5, it must go via R6. In case if any link, either link 2 or link 3 goes down, you see, let's say I'm on BT and let's say that serial 1 by 1, which is link 2, has gone down. Serial 1 by 1, right? Serial 1 by 1 on BT, right? That is link 2. I've shut down it. Now we will see that for all prefixes, now traffic will be forwarded in the direction of, you see, 100.1.1. It is going via R6 now. Similarly for 2. Similarly for 3. Similarly for 4 and 4 and 5. It was already via R6, right? Its best path was already via R6. And this time for all prefixes it is forwarding traffic via R6. In case now on BT, if this link comes back up, so once again you will see that neighborship will come up, right? line protocol of this interface will come upon BT, and then they will also form BGP peering. Right. देखना क्या है, तो यहाँ क्यों दिखाएगा वो, हद हो गई भाई, इतना पढ़ा लिया कर दी सारी, तो बीटी भी नहीं दिखेंगे, ये केवल बेस्ट पाथ की इन्फॉर्मेशन एडवर्टाइज नहीं करेगा आगे। BT will advertise only best path information towards NEOP router, right? So BT is getting all these prefixes from its neighbors after prependation, and that is why you can look at here at the output of BT for first three prefixes. Best path is via R5, because from R6 it is getting higher number of ASs, more number of ASs as compared to via R5. Similarly, for last two prefixes, it is again receiving this, I mean these prefixes from R5 as well as from R6, but from R5 it is getting more ASs inside AS path list. That is why its best path has been defined via R6. Understood? So in this way, see, we didn't touch console of BT, and we have manipulated path selection of BT. So this is the way to use AS path attribute for path manipulation in BGP, right? So in previous class we discussed weight, local preference, and of course this AS path list, but today we have completed this AS path attribute now, right? So this is the way to use it. Now next attribute is going to be now origin code. After AS path attribute, let's go for origin code. So I'm going to remove it from R5 now. No route map, AS path, no access list 10. Fine. On R6, no route map, nothing. Fine. Let's talk about origin code now. As you know that origin code is well known, mandatory, right? Origin code is well known, mandatory, same as AS path. And you know very well that here in origin codes we are having three different codes. I, which means incomplete. BGP, which means that you have advertised prefixes with using network command, right? So by default origin code would be I. EGP, actual EGP, that was yes, that was developed before BGP. Nowadays you will never ever get this E. Question mark, incomplete, you can also call. Redistributed. right? So if you redistribute anything into BGP, by default its origin code will be question mark. And this is the sequence for best path selection. I will always preferred over and E is always preferred. So if you are receiving a prefix from two different neighbors with same let's say from one neighbor you are receiving prefix with origin code I, from another neighbor you are receiving prefix with the origin code question mark. So I will be preferred over question mark. But this time, and one more thing, it is also same as AS path attribute. You can use this origin code to manipulate outgoing traffic path selection. Outgoing traffic path selection, like you used weight, local preference, and again you used AS path attribute as well, right? Similarly, you can use origin code, but in actual, origin code will not be in use to manipulate your outgoing traffic path selection. In actual, we will be using this origin code in place of AS path prependation to manipulate incoming traffic path selection. To manipulate incoming traffic path selection. And you know why is it possible? Why it is possible to manipulate incoming traffic path selection with the help of origin code? Because it is a well-known mandatory. It is a well-known mandatory attribute. That is why it is also possible to manipulate incoming traffic path selection with the help of origin code. So I'll be using this origin code to manipulate path selection in both directions. First of all, I will manipulate path selection of outbound traffic, which means that a traffic which is leaving this network bull's customer network, and then we will manipulate that traffic path selection which will be entering into the network bull's network, right?
तो इसका मतलब ये कि जो वेल नोन मैंडेटरी एट्रीब्यूट्स हैं
उनसे आप इनकमिंग ट्रैफिक एग्जैक्टली हमेशा, राइट? Fine. So now we are on R1, and you can see that for all these prefixes, for 100, 101, 102, 103, for all these prefixes, best path is via R5. You can look at this. You can see show IP route BGP that for all prefixes, its best path is via R5. Let's say I want to configure its best path via R6. This is in terms of outgoing traffic, outbound traffic, right? This is in terms of outbound traffic because these prefixes are incoming prefixes, right? So show IP BGP. This time you can see that this 100.0 is coming from 5 as well as 6, but from both neighbors its origin code is I. So I wanted to configure its best path via R5, via R6. I wanted to define its best path via R6. So define its origin code as question mark via R5. Define its origin code as question mark via R5, so that its best path will be defined via R6, right? So let's say that for first two prefixes, for 100 and 101, I want to define its best path via R6. So I will do one thing. I'll create access list 10 permit 192.168 and 0.0.1.245, right? Say route map origin permit 10, match IP address 10, set origin code is what? Incomplete, right? That means question mark. To allow all others, permit, we can also take 15. That should be higher than 10. Even you can take 11. Router BGP 65500. For which neighbor you will be applying it? For R6 or for R5? For R5, because via R5 we wanted to configure its attribute as question mark, right? So for R5 I will be applying this route map. Route map name is what? Origin. In which direction? In, because all these prefixes are incoming prefixes. Now say do clear IP BGP star in. Do show IP BGP. Check it out. For first two prefixes, its best path is now via R6. So in this way, in this manner, you can manipulate path selection in BGP by modifying its origin code. Any problem? Fine. So in this way we can manipulate path selection with the help of origin code for outbound traffic actually, right? Now let's talk about inbound traffic. So let's remove it now. Say do clear IP BGP star, no route map, origin. Let's move on. Okay, fine. Let's move on R6 and say clear IP BGP star, and on R6 also I'll be saying clear IP BGP star. So we will see that it is possible that for BT, for all prefixes, for all 100 prefixes, right? For all prefixes in the range of hundreds network, best path will become link 2 only. Once again, right? So we can have a look on BT. Let's check its BGP table. It haven't received all those prefixes yet. Just wait for a moment. Yes, it has received all these prefixes from R6 first. It haven't received all these prefixes from R5 yet. Let it receive all these prefixes from R5 as well, and then we will see that which one will be best path. We have to do wait. My God. This time it's done. Let's move back again on R5, sorry BT, and see it is receiving all these hundreds prefixes from R5 as well as R6, but for all prefixes you can see that its best path is become via R6 due to oldest path, because it received these prefixes first from R6. Is not it? So based on oldest path, it has defined its best path via R6. Now again my task is same. For first 3 prefixes, best path should be via link 2, and for last 2 prefixes, best path should be via link 3. We can receive it very easily. For first 3 prefixes, we can advertise its origin code as question mark from R6. For first 3, so BT will be receiving first 3 prefixes coming from R5 as well as R6, but from R5 origin code will remain as I, whereas from R6 we will advertise it as a question mark. So automatically BT will define its best path via R5. Let's do that now. Let's move on R6 now. And on R6 I'm gonna to say do show IP access list. Actually first of all check its access list. So there is no access list. Access list and permit 100.1.0.0, 0.0.3.245, right? Then create one route map with the name of origin permit 10, match IP address 10, set origin code is what? Incomplete, and allow all others with default attributes. Go to router BGP 65500, Neighbor is 201.100.100.5. Route map name is origin. In which direction? Out. I think it's 1. Right? So say do clear IP BGP star out. Now let's move back again on BT router, and we will see that for first 3 prefixes its best path will become via R5. Check it out. Automatically, you see. Now its best path is via R5 just because of origin code. Now what do we want? That for last 2 prefixes 4 and 5, its best path, I mean BT's best path must always be link 3 if it is available, right? So let's move on. R5, say access list 10 permit 100.1.4.0 0.0.1.245. Create one route map, name is origin, permit 10, match IP address 10, set IP, set origin, right? Set origin is what? Incomplete. To allow all others, permit 20. Then go to router BGP 65500, neighbor 200.105.100.1. Route map name was in which direction? So do clear IP BGP star out. Now you can have a look at BT's output. You can see that for first 3 prefixes its best path is now via R5, and for last 2 prefixes its best path is via R6. Even you can try to trace route from Neo router, trace route 100.1.1, it's going via R5, whereas 4 must go via R6. So that's what we wanted to achieve, is not it? With the help of origin code. So in this way we can manipulate incoming traffic path selection with the help of origin code. So this is all about origin code. I hope that you people can easily implement this origin code in BGP to manipulate path selection. Next is going to be now MED, multi exit discriminator. It is optional non-transitive attribute. Optional non-transitive attribute. You know why it is optional? It's up to you whether you wanna advertise your prefixes with the metric or not with MED, right? Sometime yes, CCI yes, but I think you are for fine. So multi-exit discriminator, multi-exit discriminator, it comes under optional non-transitive category. Optional means if you want to advertise your prefixes with some metric, MED, in other words you can also call it metric, and it is same as like IGP metric, and that is why lower metric will always preferred. Right?
ऑप्शनल तो ये है कि सेट करोगे तो इफेक्टिव होगा, नॉन ट्रांजिट में क्या ट्रांजिट नहीं करती है चीजें, मतलब क्या होगा?
हाँ तो मतलब अब नहीं आओगे तो क्या करूँगा इसमें? बंक आपने भी किया था। हाँ, नहीं तो अब सर मेरी मजबूरी है देखो। ये ना क्वेश्चन वही पूछते जो नहीं आते ना। वैसे तो पता ही होता है सभी को क्या चल रहा है। चलो खैर, नॉन ट्रांजिटिव, ऑप्शनल नॉन ट्रांजिटिव का मीनिंग होता है कि एक तो ऑप्शनल है, दूसरा नॉन ट्रांजिटिव का मीनिंग होगा कि if any BGP router, if any BGP speaking router does not support this attribute, in that case it will discard all those updates which are coming with med value. ठीक है, डिस्कार्ड कर देगा. एक तो होता है कि ट्रांजिटिव का मीनिंग होता है एक्सेप्ट कर लेगा, हटा देगा उस एट्रीब्यूट को, लेकिन एक्सेप्ट कर लेगा. नॉन ट्रांजिटिव का मीनिंग होता है कि if it does not support that attribute, it will simply discard all those incoming updates. Fine. Now you have to remember, for an example, मैं बता देता हूँ कैसे कैसे रिले हो जाती है automatically, right? For an example, this is R1 and this is R2 and they are having EBGP peering. Then R2, R3, R4, let's say they are having IBGP. R2 and R3 they are having IBGP peering. R2 and R4 they are also having IBGP peering. ठीक है. If you are advertising anything like any prefix with any metric, let's say you advertised with metric 50, तो उस केस में R2 will automatically send an update towards R3 and R4 with metric 50 itself. It will not remove that because we configured it statically on a router 1 that whenever you will be giving an update to router 2, you have to attach metric as 50. So whenever R1 will be giving any update to R2, now R2 will be receiving all updates coming from R1 with metric 50. And then if R2 is having some IBGP neighbor, then it will be advertising same prefixes with same metric without modifying, right? Without removing metric. But once let's say that R3 is further having EBGP pairing with another router, now it will strip this metric. Now it will remove that metric. So remember, if you have configured statically that okay, this med should be attached in outgoing prefixes for this EBGP neighbor, then it will attach it. Otherwise, automatically whenever it will be giving an update to its EBGP neighbor, it will simply remove med value. Yes, on R3 if you configure it statically now that okay, whenever you will be advertise any prefix towards this EBGP neighbor, then you have to attach your metric as 50, then again it will start attaching this metric in all outgoing updates. So if we are, let's say if any BGP speaking router is receiving any prefix with med attribute, with any med value, then it will be giving that information to its all IBGP neighbors only. But whenever it will be giving an update to another EBGP neighbor, then it will simply strip that metric, that med value, and lower will always prefer. And usually you will be using this med to manipulate incoming traffic path selection. In most of the cases you will be using this med to manipulate incoming traffic path selection, but again there is one condition, that you must have both connections from same ISP and both connections should be terminated yes, same ISP only. You must have internet connections from same ISP. If you are having two different connections from two different ISPs, then you cannot manipulate path selection for incoming traffic based on med. In that case, in that condition, it will not be possible. Like we manipulated previously path selection with the help of AS path attribute as well as origin code. So AS path attribute, you can use AS path attribute in that condition as well, where you are having two internet connections from two different ISPs itself. Then also you can manipulate your path selection for incoming traffic with the help of AS path attribute, but with using MAD that is not possible. With MAD you can manipulate path selection for incoming traffic In that case only when you are having two different internet connections from same ISP. And this time you can see in this diagram, this customer network bulls is having two internet connections, link 2 and link 3 from same ISP, that is British Telecom. So we will be doing it in this manner. One more thing I would like to tell you, it is also possible to manipulate your outgoing traffic path selection with the help of metric. Let me do that. First of all, I'll be using this multi-exit discriminator value to manipulate outgoing traffic path selection itself. Fine. For R1, show IP BGP. To reach 192.168, 100, 101, 102, 103, its best path is via R5. You can look at here, show IP. Let me show you, show IP route BGP. So all of them are going via. What I want now, that for last two prefixes, its best path should be via R6. For last two prefixes this time, right? For 102 and 103, its best path should be via R6. So you know very well that lower med will be preferred via both neighbors. By default, its med is what? 0. Do one thing, via R5, define its med higher than via R6. So via R6 you are already having your med as 0. So define any med value via R5 higher than 0. Any value higher than 0. And all values are higher than 0 except 0. So you can take 1 as well. So do one thing to manipulate path selection for outgoing traffic for 102 and 103 prefix. We can here we can use metric. So now you can see show IP access list. We are having an access list and I'm going to remove it. No IP, sorry, no access list. Then access list and permit 192.168 102.0 0.0. Right? So we have matched 102 and 103 both. Do one thing, create one route map with the name of med. Permit match IP address, set metric 5, that's fine. And for all other prefixes, it must receive, all other prefixes must come with default attributes. So we have allowed all other prefixes as well. Now we have to apply it for neighbor. Med in which direction? Which one is best? Right? So with the help of med, we can also manipulate outgoing traffic path selection. But we are not going to use it in this manner. Because you can achieve the same task with the help of either weight or local preference. So again, I need to achieve the same task here for hundreds prefixes. Right? All these 100 prefixes, like from 100.1.0 to 5.0, right? All these prefixes are advertised by R5 and R6 towards its ISP BT. And now for the traffic coming for these prefixes will be called incoming traffic for this customer, right? So this time we want to manipulate path selection for incoming traffic. That will be forwarded by BT in the direction of customer network goals. And we want to manipulate that. So do one thing, move on R5. I want to remove the existing configuration first of all. No route map. That was origin. From R6 as well. Origin, right? BT. It is receiving all these prefixes, hundreds prefixes, see, from both neighbors, from R5 as well as from R6. And now we can do one thing, we can say clear IP BGP star, and once again we will see that which path, either via R5 or R6, will be best to reach all the hundreds prefixes, right, from BT, from service provider, right? Let's look at BT's output. So this time you can see that its best path is via R5 for all prefixes. It is via R5. And we wanna achieve the same task once again. For first three prefixes, 100.1.3, sorry, 100.1.1.0 to 100.1.3.0. It's BT's best path to reach all these prefixes must be via link 2, but in case if link 2 goes down, BT must be able to use link 3. For last two prefixes 4 and 5, link 3 must be preferred by BT. But in case if link 3 goes down, then BT must be capable to use link 2 for these prefixes. To achieve this task, because you know lower metric will always be preferred. So from R6 for last two prefixes, we will advertise higher med, and for 100.1.4.0/24 to 100.1.5.0/24 lower. For these two prefixes we will advertise lower med. And here for first three prefixes,
lower med.
lower med in outbound direction, right? And for 100.1.4.0/24 to 100.1.5.0/24, for these prefixes higher med. Right? So let's do that now. From R5, sorry, no access list. So IP access list. There is no ACL on R5. Similarly on R6. Show IP access list, say no. Once again say show IP access list. Any problem? Now I'll be creating two access list on R5. Access list 1, permit 100.1.0.0, 0.0.3.245, so that first three prefixes will match with this ACL, right? Another ACL, access list 2, permit. This is not a different statement, this is different ACL actually. 100.1.4.0, 0.0.1.5. I'll be creating now route map with the name of med permit 10. Match IP address 1, ACL 1. In first ACL I have matched first three prefixes. I'll say set metric, how much? Let's say 1 itself. You understand? Create one another statement of the route map. Permit match IP address 2. Set metric, higher metric, let's say it is 2. And all other prefix, if we are advertising any other prefix, rather apart from hundreds prefixes, also we are having some other prefixes, right, which are advertised towards. So we can create another statement with higher sequence number. Do not match anything, do not set anything. So all other prefixes will be advertised towards this BT with the default attributes. Go to router BGP 65500, say neighbor, I think it is 200.105.100.1, route map name is med in which direction? So do clear IP BGP star out, do show east way. Create ACLs on R6 as well. Create one route map now. Med permit match IP address, but set higher metric, right? How much? Tell me.
10 level, 20 level.
Okay, let's make it 20. Just give me 1 second, please. Fine.
Permit 20.
Set metric 20. Create another statement for the same route map with high sequence number. Say match IP address to set metric. How much? 1 is enough. Lower metric, right? And for all other prefixes, if you are having some other prefixes, then create one other statement. Third statement for the same route map 30. Don't match anything, don't set anything, and now go to router BGP 65500 neighbor. Tell me. 201.100.100.1. Route map name is med in which direction? Do clear IP BGP star out. Go to BT. Now check its BGP table. For first 3 prefixes, best path is via. For first 3, check it out. Right? And for last 2 prefixes, its best path is now via R6. You can look at here. So you can also achieve your task with the help of MED. But make sure that you are having an internet connection from the same ISP. Understood? Fine. So this is the uses of MED. Now in it we are also having some other things to do in MED itself. To achieve that, actually I'm gonna use this link 1 as well. I'll start to use this link 1 now. So I'll move on R5. Interface serial 1 by, I think this is what? Serial 1 by 0. Say no shutdown. Right? Now neighborship will come up in between sprint and R5. Fine. So R5 will start advertising prefixes into the direction of sprint with the metric, with med value. Right? And now sprint will advertise all these prefixes into the direction of BT as well. So BT will be receiving it from sprint, from R5, from R6. But you will see now that BT will define its best path. You see, now it has started to receive it from all of them. And I would like to tell you one more thing. In some cases, ISPs can also configure this command in their network, I mean on their devices. I think this is BT, so it is running 35500. They can say BGP best path. BGP best path med missing as worst, which means that if any prefix is not coming with any med value, then it will automatically define its metric as worst metric, the highest metric. And previously you can see that it is receiving metric from R5, from R6, but it is not receiving from 101.1.1, which is a sprint. Once I will configure this command, now you see, you look at BGP table. So sometimes even you will require to advertise your prefixes after adding some metric, because if you do not advertise your prefixes with metric, with the med value, might be possible that they have configured this command on their router, and I mean, your metric would be higher now. I mean, some problems can occur due to this thing.
What is the purpose of configuring this command that I explained?
So that if you are receiving with the lower metric, because if you redistribute anything, any IGP into BGP, metric of IGP will be copied into BGP as met, right? And if you are receiving prefixes from two different neighbors, from one neighbor you are not getting any met, and from one neighbor you are receiving some metric value. So now via that neighbor from where it is not receiving any value, any met value, then it will configure its met value as worst, so that it will not be preferred path now. And best path will become that path from where it is receiving prefix with met.
But if we
with
do not
metric.
configure this command, then what is the value it assumes for that prefix?
Zero. Right? So this is the way to do it actually. Right? So they can also configure this command. So now I'm gonna to do one more thing here. I'll say router. Okay, leave it, let it be, because it will not create any big difference over here. You see, show IP BGP, its best path is via R5 for 100.1.0, right? You know why? First of all, it will compare what? Tell me. Weight is equal, local preference is also equal, because it is blank for all three, right? It is blank, which means by default it will consider its local preference as 100 by default, right? Next is AS path. So now sprint is out of selection based on AS path attribute. Finally, selection will be performed in between R5 and R6, and origin code is same. Finally, MED is there. Got it? Now my task is bit different now. Task is that only for one prefix, and that is 100.1.0/24. For this prefix, BT's best path should be via sprint. Only for this prefix. Because I want to use this link one as well. I want to utilize this link one as well, right? Because right now, if I am sending any traffic from New York router towards Network Bull's customer, then BT will be using either link 2 or link 3. It will never forward traffic into the direction of sprint, which means that link 1 will be completely unused, but I want to use that link now. Now problem is, if I am advertising any MED value from R5 towards sprint, then sprint will never forward that MED value towards BT by default, because as I told you that whenever updates will be forwarded, will be advertised towards eBGP neighbor, then MED value will be stripped out. Right? Right? So this is my task now. How can we achieve it? To do that, I have to contact now Sprint US. That's what I need to do now, right? We have to call Sprint service provider. That do one thing, whenever you will advertise this particular prefix towards BT, advertise it with this metric. So let's say I asked Sprint to advertise this particular prefix with the metric 0. That is the lowest one, right? And you have to ask to Sprint US, and now it will be depending on Sprint US whether they agree on your point or not. If they are not agree, you can't say anything, right? It will be mentioned in your agreement in between you and your service provider. And if they are agree, then they will do it in this manner. Go to Sprint US, say access list 1 permit 100.1.0, only this prefix, create one route map with the name of MED permit 10 match IP address 1 set metric 0 for all other prefixes. Don't match, don't set. All other prefixes will be advertised with default attribute. Now go to router BGP. I think it is using 21545 and the neighbor is 101.1.1. I think so. No, it is 2. 2 is configured at the end of BT, right? So now go back to Sprint and say route map name is mad in which direction. That's fine. Say clear IP BCP star. Go to BT. Wow, for hundreds prefix, its met is now 0 via 101.1.1. You understand? And for all other prefixes, still it is receiving default one. That is why it has configured worst metric worst metric for all other prefixes, right? Via Sprint, this BT. But still, its best path is via based due to AS path attribute. Because before MED it will be comparing AS path. But there is a feature in BGP, not feature actually, or you can say there is a hidden command in BGP by which you can bypass AS path attribute. So do one thing, router BGP it is using 35500 BGP best path. This command is hidden command. It will never show you in the output of question mark. So once you will configure this command now, it must define its best path via Sprint US based on MED clear IP BGP star. I'm doing hard reset now so that we must be able to get appropriate result. Have a look once again at its BGP table. Once again it is receiving it from all of them, but still its best path is via R5. Still its best path is via R5. You know why? You must remember, let's say this is ISP router and this is your customer, and customer is having two customer edge router, customer edge 1 and this is customer edge 2. But you know customer is using common AS, right? 65500. And if ISP is receiving same prefix from same AS with the different metric, then it can compare their MED values. Then only it can compare MED values if it is receiving prefixes from same AS. So this time BT was receiving, in previous example, BT was receiving prefixes from 65500. That was the same AS with the different metric. From here it was receiving metric 1 and from here it was receiving 20. So it defined it as best. But always remember, if you are receiving, like let's say that this is your customer edge 1 and this is customer edge 2, but both customers are in different ASs. Let's say it is in 65501 and this is in 65502. Right? So
now it will treat them as different ISPs.
Now, yes, now you see this is your ISP, right? And it is receiving same prefix coming from this customer edge 1 as well as customer edge 2, but this time it will not compare their MED values. To compare MED values, it is mandatory to receive prefixes from same AS. In previous example, this BT was receiving prefixes coming from same AS, but this time it is also receiving from Sprint. That is why it is not considering that metric, that prefix. You understand? So now if you want to force BT, like you can also modify this rule, right? If you wanna compare their metric in that condition as well, where it is receiving prefixes from different ASs, then you have to give this command, router BGP 65500 sorry, it is using 35500 BGP best path I think this is BGP
router will change.
import router BGP 35500 BGP always continue, right? Once you will put this command in router mode, then after say show IP and once again say clear IP BGP hard reset, right? Once again perform hard reset. Once you will perform now hard reset, you will see that now BT must define its best path for first prefix via sprint. Check it out. Right? You can look at show IP route BGP. Check it out. For 100.1.0, best path is via 101.1. Right? So this is BGP. Whatever you want to achieve, you can achieve. This is all about path manipulation, and this is the most important thing when it comes to enterprise network. Right? So this is all about MED. And IGP goes to reach next hop, we already covered it. Because after MED, that is IGP goes to reach next hop. Sorry, after MED it is external internal and we cannot modify that. If you are receiving prefixes coming from eBGP neighbor, which means your AD value will be 20 external prefixes, right? If you are receiving anything from your iBGP neighbor, then by default its AD value will be 200. Understood? Any problem in it? All right. Now, once again, I'm gonna to remove all these things that I configured over here. And is there any problem with the IGP cost to reach next hop now? Like I already proved it on R1. Like from R1 next hop is like R5's loopback as well as R6 loopback, and we saw that okay, it was preferring by R5 just because of lower ICP cost to reach next hop, right? Then we configured same ICP cost to reach next hop by R5 as well as by R6, right? So you can manipulate your path selection by modifying ICP cost to reach next hop. Then we also modified best path selection by modifying their router IDs as well. We saw that okay, how BGP defines its best path based on router IDs, and final was I think lower neighbor address, and we saw that based on yes last not attribute, we will say tiebreaker. Last tiebreaker was lower neighbor address, because it is also possible that okay, your neighbors can have same router IDs. It is also possible to have in BGP, right? So we have covered all the attributes of BGP. Now we have seen that in which conditions, in which circumstances, which attribute will take place, or you should use which attribute in which conditions, because it is really important to understand situations. According to situations, according to the circumstances, you have to select your attribute to perform path manipulation, right? Now listen, I'll show you that med will always be carry forward in updates while it will be giving an update to its IBGP neighbors. What can we do? On BT, see BT is advertising these prefixes, right, towards R5 as well as R6. From BT we can advertise these prefixes towards R5 and R6 with using some med value. Just to prove it, right? So that we will see that R5 and R6 will be forwarding those prefixes towards R1 with med. So let's do one thing. Let's move on BT now and say route map med permit 10. Match all is by default there. Say set metric is what? 10. Create one another route map med for R6. Permit 10. Match by default match all is there. Set metric how much? 20. So that link 2 will be preferred, right, by customer. Link 2 would be preferred, right? Via link 2 I'm advertising lower metric. So I'll say router BCP 35500 neighbor, I think that is 200.105.100.5. route map name is med. In which direction? Out. Say neighbor 201.100.100.6. route map name is med for R6 and out. Say do clear IPBCP star out. Fine. Move on R1. I have not modified anything over here, right? But now you look at here. Its best path is via R5. Automatically. Not only for this, even you can look at R6 itself. So IPBGP. Check it out. Its best path is via R5 itself. Because the AS path attribute is same. Origin code is same. Finally, med was compared. Then lower med is preferred. So even ISP can also manipulate path selection of customer. It's not it. Hey, this is similar thing that we performed in previous section, in previous example. The only difference is this time we are having multiple devices in this AS. And in the first example, I was having only single device in AS 35500, but this time I was having multiple devices in AS 65500. So we have seen that R5 and R6, when they are giving an update to their IBGP neighbor R1, they are giving those updates with metric. Now in case if R1 is having EBGP neighbor with R2, let's say that we configured EBGP pairing between R1 and R2, then you will see that R1 will be forwarding an update towards R2 after stripping med. It will not include med value along with updates, while it will be giving an update to its EBGP neighbors. So this is the thing, right? I have removed it once again. So this is all about path attributes. We have covered all path attributes now in BGP. After it, let's go for load balancing. By default, BGP does not perform load balancing. By default in BGP maximum path is 1. However, in all IGPs, by default maximum path was 4. That is why it was possible for IGPs to perform load balancing among 4 paths. And they were performing equal cost load balancing. However, EICRP could perform unequal to. Right? That's different thing. So let's move on R1. R1 is once again receiving all these prefixes coming from both neighbors. Everything is looking same now, right? But still, you can look at show IP route BGP. It is not performing equal cost load balancing just because of show IP protocol. You can look at here in BGP by default maximum path is 1. If you wanna perform equal cost load balancing, right? We know very well that all the attributes are same. So we can say router BGP 65500. See, your attributes are just up to IGP cost to reach next hop, and then after you are having only tiebreakers, not attributes. All others are called tiebreakers, not attributes. So remember, your all attributes must be same to perform equal cost load balancing, not tiebreakers.
So tiebreakers will not be.
Of course, it is not mandatory to have same tiebreakers to perform, and even you cannot have tiebreakers same at all. You cannot have common tiebreakers. It's not possible to have same neighbor's IP address. You can have same neighbor's router ID, but you cannot have same neighbor's IP address. So remember that all attributes up to IGP cost to reach next hop must be same to perform equal cost load balancing in BGP. Up to IGP cost to reach next hop, and after external over internal we are having IGP cost to reach next hop. So all the BGP attributes up to IGP cost to reach next hop, you understand, must be same to achieve load balancing, equal cost load balancing. Fine, so I'm going to do that now. On R1 I'll say maximum paths 2, right? Show IP route BGP. Is there any difference? No, still it is not performing equal cost load balancing. You know why? Because when you said 65500 maximum path 2, it was changed only for eBGP neighbor, not for IBGP. And this time R1 is receiving all these prefixes coming from 2 different IBGP neighbors only, right? So if you wanna change maximum path for IBGP neighbor, then you have to say maximum paths IBGP, and that's a 2. So if you are receiving prefixes from 2 different eBGP neighbor, and then you want to perform equal cost load balancing for them, then you have to say maximum path 2 or 3, whatever it is, right? And if you are having IBGP neighbors, then you have to say maximum path IBGP. That is a bit confusing, right? So you have to be very careful while you are changing your maximum path, because it will be depending on your neighbor types. If your neighbors are eBGP neighbors, if both neighbors are eBGP neighbors, right, then you will simply say maximum paths 2. If your neighbors are IBGP neighbors, then you have to include this keyword maximum paths IBGP and then maximum path value, right? So this time show IP route BGP. Still it is not performing equal cost load balancing. You know why? Because show IP BGP 192.168.100.0 IGP cost to reach next hop via both neighbors is not same. And I told you that to get equal cost load balancing, all the attributes up to IGP cost to reach next hop must be same. And to make it same, what can we say? We can move on R4, and on R4's F2 by 0 configure its cost as 64, same as serial 1 by 1. So move on R4 now, go to interface fast Ethernet, tell me fast Ethernet 2 by 0, IP SPF cost is 64. Now you will see that from R1 cost to reach both next hop will become same. Just wait for a moment. Changes will take some time. You see now it is, and now it has started to show you multipath. In details, if it is showing you multipath, which means that it is performing equal cost load balancing, which means that it has installed both of them into its routing table. Now you can see show IP route BGP. So wherever you will find this multipath, which means it is performing equal cost load balancing. You see now everything is same, right? Up to ICP cost to reach next hop. Understood? So this is the way to perform equal cost load balancing for IBGP neighbors. What about eBGP? Like you can look at British Telecom now, right? On British Telecom, so IPBGP, You are receiving all these 100 prefixes coming from eBGP neighbors, right? If we want to perform equal cost load balancing, then what can we say? Router BGP 35500, we can simply say maximum paths 3, right? Show IP route BGP. Check it out. You see, it is performing equal cost load balancing, right? So this time you can see it have started to perform equal cost load balancing for external prefixes as well. You see, AD value is what? 20. Understood? Fine. After it, now we know very well that this R6 is receiving all these prefixes from its eBGP neighbor as well as IBGP neighbor. Best path is via IBGP neighbor. Best path is via IBGP neighbor. So IP route BGP. You can see that all these prefixes are coming as external prefix. External prefix is this 101, 100, 101, 102, 103, right? And AD value is what? 20. Now everything is working fine. Everything was working fine, and you know, there is no problem. Later on, company decided to have a backdoor link. F0 by 0, F0 by 1. This is F0 by 0 and this is F0 by. They are having now backdoor link line in between. Customer has 2, this is customer has 1, right? Customer has 1 and this is what? Customer has. Between customer has 2 and New York router, they are having a lease line now for redundancy purpose, right? Let's say here you configured IP addresses on R6 F0 by 0. IP address, let's say 192.11.1, right? Or 11.6 on R6. And then I'll move on New York router. On New York router, I'm using fast Ethernet, tell me 0 by 1, and it is going to use, let's say 11.1. And then we decided to use EICRP between them. Router EICRP 100, node assembly network. Let's say it is 0, 0, 0. I went on R6 and then I said router EICRP 100 node assembly and network 192.168.11.0. It must form neighborship with New York router. Yes, it has formed. It has formed EICRP neighborship, right? Now it must start receiving prefixes coming from New York router with the help of EICRP as well, right? So IP EICRP topology, check it out. So all of them are there, but all of them are, they are present in its topology table, but in its routing table, you see, it will still have all those prefixes with the help of BGP, because via BGP its AD value is what? 20, and via EICRP it is 90. So you can look at IP route 192.168.100.0. So it is still received via BGP, you see, just because of AD value. Now whenever you will forward traffic for all these prefixes, it will go via either link 2 or link 3. It will never use backdoor link. And if you are not using your backdoor link for any single prefix, then how will it be possible for you to track this link? There should be something so that you can track this link whether it is up or down. Let's say for a single prefix, let's say that you decided for 103, for 102 actually, for 102 only, for R6 you want to define its best path via EICRP. You understand? You want to send traffic via EICRP, via backdoor link for 102 prefix, for this prefix only. So you can do one thing, you can move on R6 and there is a command in BGP that network 192.168.102.0, and then you can add backdoor keyword. Once you will add this backdoor keyword, now it will change its AD value from 20 to 200. It will change its AD value from 20 to 200. It will treat as a, you know, like internal prefix now. It will treat this prefix as a internal prefix. So in place of 20, it will make it now 200. Once it will configure it as a 200, now it will start preferring EICRP. Even you can look at here, show IP route EICRP. It will be having only this route in its routing table via EICRP. Even you can say show IP route 192.168.102.0. Check it out.
Why it is showing redistricting? Why EIRP?
तो क्या दिखाएगा? हमेशा देखना, डिटेल देखोगे ना राउट में, ये जीआरपी ऐसे दिखाएगा, वो रीडिस्ट्रीब्यूटिंग हमेशा ऐसे दिखाता है।
इन्होंने बैकडोर लगाया, रीडिस्ट्रीब्यूट तो नहीं किया ना?
हाँ, ये हमेशा ऐसे दिखाएगा, नॉर्मल EICRP में भी, नॉर्मल में भी ऐसे दिखाएगा। चलो मैं दिखा देता हूँ तुम्हें कैसे। नो राउटर EICRP, sorry, no router BGP 655. First of all, let me have running config of it. And no router BGP 655. Right now there is no BGP, but still it will show you that redistributed. ये नॉर्मल बिहेवियर है, मतलब ऐसा दिखाता ही है, राइट? नाउ जस्ट कॉपी एंड पेस्ट वंस अगेन द कॉन्फ़िगरेशन ऑफ BGP. अब कहाँ से बढ़ाऊँ, इसमें इतना ही दिया इन्होंने, अब दो गई भाई, इतना ही है का क्या मतलब है? होता तो बताता मैं तुम्हें खुद से। फाइन, सो we have covered all these things in BGP now. I mean, like how to perform equal cost load balancing, how to use this backdoor keyword, how to use GRE tunnel and everything, how to modify next hop address, what is the uses of next hop address, what is synchronization rule in BGP, right? What is transit AS and everything, path attributes, everything. Let's go for summarization, right? I'm gonna remove this link. So once again this R6 will start receiving all these prefixes with the help of BGP only, you see, and still in routing table it will show you its AD value as 200 because this time EICRP will be removed, right? So if you route BGP, check it out, this 102 is there, but its AD value is what? Just because of that backdoor keyword. Fine. So this time you can see that R5 and R6 are advertising all these prefixes towards R1. I mean, these are customized router and they are enough capable to hold a huge, routing table. But R1 is not having very good hardware configuration. So we decided to configure summarization on customized router so that whenever they will advertise any prefix towards their IPGP neighbor, they will advertise only and only summary address, right? So all these prefixes in the range of 192's network are advertised by R5 and R6 towards their IPGP neighbor R1 individually. But this time we want that R5 and R6 must perform aggregation. So what can we say on R5? In router mode, we can say aggregate address, and then your aggregate address that is going to be 100.0, 255, 255, 2, tell me, 252 or 248? Tell me.
248. 248.
Sure. Why not 252? सही तो आ गया ये, पूरा तो आ गया। 100, 101, 102, 103 आएगा इस ब्लॉक में। ब्लॉक साइज निकाल लो ना। We took 2 bits in third octet, which means block size will be 4. 0 to 3, 4 to 7 निकालते रहो, एक आ जाएगा 100 to 103. Fine. Just press enter. Similarly, I'll be configuring R6 router BGP 655.00 aggregate address. show IP BGP. Check it out. Yes. But along with this aggregate address, it is still receiving all the individual prefixes, right? So for that purpose in BGP, it is mandatory to say summary only. Similarly on R6, say now you go back to R1, you must get only and only. It has suppressed all others. You can look at R5, do show IP BGP. You will see that it has suppressed all these prefixes now into a summary address, and this is your summary address advertised by this router. And it will also create a null entry, discard entry, do show IP route. You can check it out. Just for loop prevention. So many things are there in route summarization in BGP. So many things. पहले इसको पढ़ के आओ थोड़ा सा खुद से, बुक है सभी के पास. Go through your book and tomorrow I will go for the summarization, because a lot of things are there like suppress map, advertise map, attribute map, and suppress map. A lot of maps are there. Even you can also use route maps.